Now we have already seen arithmetic progression, arithmetic series, arithmetic mean. Now, in the previous session, we saw geometric progression. So now let's look at geometric series. So we have this geometric series. What would be the value that we'll arrive at when we sum up all these terms in this series? That depends on R. So when the absolute value of R is equal to 1, that implies R is equal to plus or minus 1. So for R equal to 1, we have A plus A plus A n times, which is nothing but n times A. So here, when R is 1, R and its powers, they all disappear. Only A's are left. Now, when R is not equal to 1, that is where things happen. So here we have this series, and here R is not equal to 1. Let's figure out what the series is. We will use a technique pretty similar to what we did in case of arithmetic series. There we had the common difference. Here we have a common ratio. So we multiply S sub n with R. What happens if we multiply with R? This will become AR to the power of 1. This will become AR square. This will become AR cube, and so on. And the last term will become AR to the power of n. Now we subtract the 2. We get S sub n minus R times S sub n equal to, now the right hand side, what will happen? AR1, AR1, AR2, AR2, AR3, AR3, AR4, AR4, ARn minus 1 and ARn minus 1 here will cancel out. And we are left with only AR0 and ARn. Let's simplify that. We get S sub n times 1 minus R equal to A times 1 minus R to the power of n. So that we end up with S sub n is equal to A times 1 minus R to the power of n divided by 1 minus R. We can stick with this, or we can multiply both the denominator and the numerator with minus 1 and get S sub n is equal to A times R to the power of n minus 1 by R minus 1. So stick to this or stick to this. Both will work. The only thing is be consistent. Otherwise, confusion happens. So this formula is valid only when R is not equal to 1. So let's dig deeper. When R is equal to 1, the formula itself is not valid, because in the denominator we will end up with 1 minus 1, 0. So in that denominator we can't have 0. So the formula itself is not valid, but we know that the finite sum is n times A. That means S sub n is equal to A times n. And if we take the sum to infinity, that means infinite number of terms, if we add up, it will go to plus or minus infinity depending on the sign of A. Now what happens when R is equal to minus 1? S sub n is equal to, we apply the formula, A times R to the power of n minus 1 by R minus 1. So A times R to the power of n is what? Because R is minus 1, we will have minus 1 to the power of n minus 1 by minus 1 minus 1, which is equal to A times 1 minus minus 1 to the power of n divided by 2. Now here what I have done is the minus in the denominator, we have -1, -1, -2 it becomes. That minus I have taken up and switched the terms here. So now this -1 to the power of n will be 1 when n is even. So our sum becomes S sub n equal to a times 1 minus 1 by 2, which is 0. But if n is odd, -1 to the power of n will be -1. So S sub n equal to a times 1 minus -1 by 2, which is equal to a times 2 by 2, which is a. If we take it to infinity, S sub infinity does not exist since the partial sums alternate between 0 and a. So that was the case when r is equal to -1. Now let's look at the case when the magnitude of r or the absolute value of r is less than 1 and n goes to infinity. Now, absolute value of r is less than 1 basically means that r is between -1 and 1. -1 and 1 themselves are not included, which means r is a fraction. So r to the power of n goes to 0 as n goes to infinity. It is very easy to figure out this part because take any fraction, say 1 by 2, square it, you get 1 by 4. Cube it, you will get 1 by 8. Take it to the power of 4, you get 1 by 16. It is becoming smaller and smaller and smaller. So as n goes to infinity, r to the power of n will go to 0. So S sub infinity is equal to a times r to the power of n. That goes to 0. So 0 minus 1 by r minus 1, which is equal to minus a times -1, minus a by r minus 1. And just to, uh, not have that negative sign, let's multiply both numerator and denominator by -1. So we get a by 1 minus r. So when r is a fraction, the formula becomes a by 1 minus r. So that implies S sub infinity will be a finite value as n goes to infinity when the absolute value of r is less than 1. Or we can write it like this as well. S sub infinity is equal to summation k equal to 0 to infinity of a times r to the power of k is equal to a by 1 minus r. So we say that the series converges to a particular value. We have seen when it is equal to 1. We have seen when it is equal to -1. We have seen when it is between -1 and 1. So now we have to look at two other cases. That is when r is greater than 1 and when r is less than -1. So when r is greater than 1 and n goes to infinity, what happens? S sub infinity is equal to plus or minus infinity depending on the sign of a. Because when r is a positive number, all the terms will be positive or negative depending on the sign of a. Now, when r is less than -1 and n goes to infinity, the signs keep alternating and the value of the accumulated sum keeps increasing and decreasing. But more importantly, their magnitude keeps increasing without bound as n goes to infinity. That means the partial sums keep oscillating between negative and positive values while their magnitude keeps increasing. So S sub infinity does not exist. Now here I have used the term partial sum. What does that mean? So partial sum S sub n is the sum of first n terms. So S sub 1 is equal to T1, S sub 2 is equal to T1 plus T2, or we can say S1 plus T2. S sub 3 is equal to S sub 2 plus T3. S sub 4 is equal to S sub 3 plus T4. So basically what this means is that at every step, we have the accumulated sum to which we are adding the next term. So in general, it becomes S sub n is equal to S sub n minus 1 plus T sub n. As I mentioned in the previous session, where we looked at with some examples, the impact of R on the progression. This is very, very important. So that was geometric series. Now, if you found this session helpful, don't forget to like, share, and subscribe. Questions, suggestions, and comments are always welcome. Thanks for watching. See you in the next session. That's it for now.